Hi all. See this, in this particular problem which is appeared in JEE Advanced 2015, what it's talked about? It says that we are having P and Q, they are two distinct points on a parabola, okay? Y square equal to 2x. So y square equal to 2x means it's open towards the x-axis, x right hand, so this side, okay? And it says that again we have to draw a circle, assuming that PQ is the diameter, and it says that that particular circle, right, is actually intersect or pass, sorry, not intersect, pass through that origin, right? So this is the given information, right? So let's see that what it's talk about. So first, let us draw the x-axis and y-axis, right? That's obviously need to be drawn to understand that problem, right? So we draw that y square equal to 2x. So this is obviously a parabola, approximate parabola. Okay, that's a parabola. So y square equal to 2x, that's the parabola. Now we consider two arbitrary points here, right? So let's take that two arbitrary point as P and Q as it's said, right? So P and Q is there, and they say that we have to draw a circle having PQ as the diameter. So PQ is the diameter and we draw a circle, right? So see that we are drawing a dotted circle, very light, but that's okay. We understand that's a circle, okay? So we draw a circle which is PQ, right? So this is passed through the point origin. So this is its given condition, and also says that the area of the triangle OP and Q, right, it's actually 3 root 2, okay? That's the given condition. So based on that, this is the given conditions and everything is there. Now it says that find the coordinate of the point P, okay? So that's our main job, that how the P can be found out, and only says that P lies on, right, in the point in the first quadrant. So P is first quadrant, okay, that's it. So see that we'll start our understand problem with this equation of the parabola, okay. So let's start that. So we'll say that the parabola it's y square equal to 2x. So that's implied that this parabola can be written as y squared equal to 4 into 1 by 2 into x. So we just write down in the general form of y squared equal to 4x. So therefore, any point on the parabola so what is the condition of any point in the parabola? Is actually at square and 2at. And in this particular problem, a is equal to 1 by 2. So therefore, any point in this parabola can be taken as t square divided by 2 comma t. So that's the any point on the parabola. Now see that P and Q are the point lies on the parabola. So therefore, we can say that what is the coordinate of P and Q. So we just assume that. So therefore, we assume that the coordinate of P is t1 square divided by 2 comma t1. The point Q is actually equal to t2 square divided by 2 comma t2 for some real values of t1 and t2, okay? That's it. So these 2 points we obtained. Now see that as PQ is the diameter, right? And the circle is passing through the point O. So therefore, the angle POQ is 90 degree, right? Because this is the angle in the semicircle. So therefore, we'll say that as angle POQ is the angle in a semicircle. So therefore, the angle POQ is equal to 90 degree. That means that OP and OQ are perpendicular. So OP and OQ are perpendicular. Let's find out the slope now. The slope of OP. Let us consider it as M1. So M1 is equal to P. P is that. So therefore, Y2 minus Y1. So T1 divided by T1 square divided by 2. That's imply that 2 divided by T1. And slope of OQ let us consider as m2, that's equal to t2 divided by t2 square divided by 2, that's imply that 2 by t2. Now m1 and m2 must be 90 perpendicular. So m1 m2 is actually -1 because OP and OQ are perpendicular. So this is the condition of perpendicularity. So let's substitute that. So therefore we can imply that 4 divided by t1 t2 is equal to -1. That's imply that t1 t2 is equal to -4. So that's the first condition between t1 and t2. That's it. So you are able to obtain, right, that T1 and T2. Now our job is to calculate some other relation between that T1 and T2. So that's why he'll use the area of the triangle. So the area of the triangle OPQ. Let's go ahead and use the determinant to represent that area. So therefore it will be T1 square by 2. Then T1 1, then T2 square divided by 2, T2 and 1, then it will be 0 and 1. Now see that it is a determinant which represent the area. Now if we expand with respect to the third row, right, because in the third row 2 zeros are present. So expanding with respect to the third row, we can easily calculate that this value is actually equal to 1 by 2. Then take a bracket, T1 square T2 divided by 2 minus T2 square T1 divided by 2. So take 1 by 4 T1 T2 common. It gives me that T1 minus T2. Now T1 T2 is equal to -4. That's imply that minus of T1 minus T2, and that's the area. This must be T1. Now, that's it. Okay. So, we calculate that area in the form of determinant. Now, we have to assume that this value is definitely equal to 3 root 2. It is given. So, therefore, we will say that T1 minus T2 is equal to minus 3 root 2. So, T1 minus T2 is equal to minus 3 root 2. So, that's the condition of second equation. So we are having the second equation here, we are having the first equation. Now if we are able to solve these two equations 1 and 2 by the linear equation, the simultaneous method, right? So definitely we are able to find out the value of T1 and T2, and then we can find this PQ value coordinates and all that stuff, right? So let's go ahead and calculate these values, right? So by 1 and 2 we just used to simplify. So first we consider the system of equation as T1, T2, right? So let's go ahead. So we'll calculate, we square them up first. So T1 plus T2 whole square, it's equal to T1 minus T2 whole square plus 4T1 T2. That's imply that T1 minus T2 whole square means that it's minus 3 root 2 whole square minus 4 T1 T2 is equal to minus 4. That's it. So 3 3s are 9 2. So 18 minus 16, that's 2. That's imply that T1 plus T2 is equal to plus minus of root 2. Now if I consider T1 minus T2 is equal to minus 3 root 2 and T1 plus T2 is equal to plus root 2. So that set of equation, if we add and subtract, we'll get at that T1 is equal to minus root 2. Just solve that equation. And if T1 is equal to minus root 2, we'll get T2 is equal to 2 root 2. So that's the one pair of values of T1 and T2, okay? That's it. Now see that, right? We have to go ahead and calculate the other equation as well, right? So this solve, we just add that equation. So 2T1 is equal to minus 2 root 2, and that's it. So now we'll just take that minus sign. So therefore we'll get it as T1 minus T2 is equal to minus 3 root 2. And T1 plus T2 is equal to minus root 2. So if I solve it now, we'll get it as T1 is equal to minus 2 root 2 and T2 is equal to root 2. So that's it. So we get two values of T1 and two values of T2. So based on that, we can get that calculation of P and Q, right? So let's go ahead and find the possible values of P and Q. So therefore, if I consider the first equation, so therefore, for T1 equal to minus 2, right? So I just wrote it as case A. This is the case B. So for case A, the coordinate of P, what's that? It's T1 square by 2. T1 square by 2 is minus 1. Then T1 is equal to minus root 2. And Q, the coordinate of Q, is equal to 2 root 2. So 2 to 4 into 2, 8 by 2. So that's 4. So 4 and 2 root 2. That's it. And case B, that's P will come back as 4 minus 2 root 2 and Q is equal to 1 and root 2. So just substitute the appropriate values. So these are the possible values of P and Q. But here one concern is there. See that it says that P and P lies on first quadrant, okay? And this name, right, will interchange, right? Based on that, see that 1 root 2, right? This is the point Q, right? But Q is obviously in second quadrant as the picture. So therefore we can say that this point will be P in this case and this is the point Q in other case, right? Because it will change based on the coordinate, right? So that's it. So therefore we'll say that as P lies on quadrant 1, so the possible values of the quadrant P is equal to 1 and root 2 and also the coordinate of P is equal to 4 into 2 root 2. That's it. So these are the coordinate of P. So the corresponding Q will be the other two values. So in that case, right, we can say that this is actually P and this is actually P, okay? So based on our drawing and everything and how the formulation is done, right? So here, this point will become that point P and the Q is become point 2, right? So that's it. So that's the way of my writing, right? But that's it. So therefore, for this particular problem, we understand that the option A and P is equal to 1 root 2, that's option D is the correct answer. So here only that's the problem, right? Because here we have to always remember that whenever the sketch is done, right, and we solved a particular problem, right? So in that case, right, here we will say that the point lies in that, so T1 will be greater than 0, right? So if I want to maintain that from the beginning, so in that case we have to consider that here, okay? So this T1 will be greater than 0, right? So T1 greater than 0 and here T2 is less than 0, right? So based on that, T1, T2 need to be decided, right? That creates a confusion, okay? So that's why we just calculate all the values and based on the first coordinate, it will change. So therefore, we'll say that this is P, this is Q, this is P, this is Q, and that's it, right? That doesn't change that much, okay? So that's it. Hope you understood the problem. Thank you.